Hi, welcome to Computer Science Explained. In this video, we will talk about fixed point versus floating point. Three main advantages of fixed point are: first, speed. There is no need to multiply mantissa and exponent, because in fixed point there is no exponent. Second, precision, or number of bits for mantissa. All available bits in fixed point are used for mantissa because there is no exponent in fixed point notation. This helps increase precision. Third, effective use of memory. Fixed point has no duplicates. All memory is used efficiently. Two main advantages of floating point are: first, range, or difference between maximum number and minimum number. Floating point can store positive and negative numbers with extremely large absolute values. Second, fixed point is perfect for storing not only numbers with extremely large absolute values, but also positive and negative fractions with extremely small absolute values. Let's talk about speed, the first advantage of fixed point. For example, we have 8 bits for a number in both fixed point and floating point. Let's calculate this number in fixed point. 2 plus 1 plus 1 over 4 equals 3 and 1 over 4. Fixed point notation consists only of mantissa and have no exponent, so there is no need to multiply mantissa and exponent. Let's calculate the same number in floating point. For example, we have 5 bits for mantissa and 3 bits for exponent. Mantissa equals 1 over 2 plus 1 over 4 plus 1 over 16 and equals 13 over 16. Exponent equals 2. In floating point notation, number equals mantissa times 2 to the power of exponent. So 13 over 16 times 2 to the power of 2 and equals 13 over 4 or 3 and 1 over 4. In floating point, we need to multiply mantissa and exponent. This reduces speed. Now let's talk about precision, the second advantage of fixed point. For example, we have 8 bits for a number in both fixed point and floating point. Let's calculate this number in fixed point. 8 plus 1 over 8 equals 8 and 1 over 8. Let's look at the span between the extreme left one and the extreme right one in the mantissa of the number. In this example, 7 consecutive bits are needed to store the number. If the number of available bits for mantissa is less than 7, this number cannot be represented accurately, or in other words, without approximation. If, for example, in floating point we have 5 bits for mantissa and 3 bits for exponent, we cannot represent the number 8 and 1 over 8 in floating point, because we have only 4 consecutive bits for a positive part of a number. Now let's talk about the effective use of memory, the third advantage of fixed point. Fixed point notation has no duplicates. Also, there is no need to normalize numbers in fixed point notation. For example, we have 5 bits for a number in both fixed point and floating point. This is number 1 over 4 in fixed point. Its representation is unique. Floating point notation has duplicates. For example, if we have 3 bits for mantissa and 2 bits for exponent, there are 2 variants of representing number 1 over 4. First variant, mantissa equals 1 over 4 and exponent equals 0. This variant is not normalized. Second variant, mantissa equals 1 over 2 and exponent equals -1. This variant is normalized. As we can see in floating point notation, some variants are redundant. So in floating point notation, bits are not used efficiently. Now let's talk about range, the first advantage of floating point. For example, we have 8 bits for a number in both fixed point and floating point. Let's consider two examples of fixed point notation with different positions of point. The first example can store fractions down to 1/8. Here the range is from -16 to 15 and 7/8. So the range length is almost 32. The second example can store only integer numbers. Here the range is from -128 to 127. So range length is almost 256. In fixed point, range length is proportional to 2 to the power of n, where n is the number of bits. Let's consider two examples of floating point notation with different distributions of bits between mantissa and exponent. In the first example, we have 4 bits for mantissa and 4 bits for exponent. Here range is from -1 times 2 to the power of 7, or -128, to 7/8 times 2 to the power of 7, or 112. Range length is almost 256. In the second example, we have 2 bits for mantissa and 6 bits for exponent. We can see the great difference from the additional 2 bits for the exponent. In floating point, range length is proportional to 2 to the power of 2 to the power of n, where n is the number of bits of exponent. Now let's talk about storing extremely large and extremely small numbers. The second advantage of floating point. We already considered examples with extremely large numbers when discussing range, so let's see examples with extremely small numbers. For example, we have 8 bits for a number in both fixed point and floating point. The smallest possible absolute value that we can store in fixed point is 1/128. The smallest possible absolute value that can be stored in floating point is 1/2 times 2 to the power of -32. Now let's talk about the great disadvantage of floating point. Floating point is great for storing extremely large values or extremely small values, but not both of them simultaneously. So we cannot store very large numbers with very small fractional parts. Moreover, if we add a very large number and a very small number, small part will disappear from the result, because the large part is more important than the small part, but there are no available bits for storing the fractional part. Thanks for watching. See you next time.